I want you guys to look at these tables right now and look at this graph right here. Okay, we're going to look at this graph and talk about these tables. Okay, you're supposed to plug these numbers into this, these numbers into this, and these numbers into this. Okay, and when you plug those numbers into it, you get y values, and you notice a trend. There should be a trend that you see. Okay, now here, check it out. If you are plugging in, and we're not going to actually calculate it, we're just going to talk about it verbally, okay? If you're plugging in 0.5, 0.9, 0.99, 0.9999, you guys told me earlier that those numbers are increasing and they're getting closer and closer to 1, right? When we're plugging in x values. So look at this right here. What's happening as we're plugging in these numbers right here as we get closer and closer to 1 right there? What are the y values becoming? More and more negative, right? You're getting bigger and bigger negative numbers because as you're getting closer to 1, this line's going farther and farther down, and you're getting bigger negative numbers the closer you get to 1. So you should expect to see like a small negative number, and then a bigger negative number, and then a bigger negative number, and a really big negative number. You guys got that? So what would you expect to see for these y values as you're approaching 1 from the right side? The numbers, the y numbers, should be getting bigger, 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 but now they're positive. Yeah, right? So you see this going there. Well, guys, what is happening right here at 1? What is this? That's a vertical asymptote. You were right. These ones right here, these two tables relate to the vertical asymptote. So check this one out right here. This one's interesting. The numbers are not approaching any specific number. They're just getting bigger and bigger and bigger. So they're approaching what? Infinity. So as x's are approaching infinity, what is this? What are the y values approaching? What are these y values approaching and getting closer and closer to, but never actually touching 0? Yeah, they're getting closer and closer to 0. And in this graph right here, what is your horizontal asymptote? 1. It is 0. Not vertical asymptote, the horizontal asymptote. The horizontal asymptote equals 0. You guys tracking with me? Okay, that's the point of these tables. If you guys fill out those numbers, you'll see that. Okay, you'll see what the numbers are approaching, and it relates directly to the asymptotes. Now, let's do a quick review really fast about these asymptotes, okay? Let's talk about the horizontal asymptotes because there's more to talk about with those, okay? You have two scenarios. When you can have a smaller number on top, bigger number on bottom, or a smaller number on bottom and bigger number on top. Which one do you guys like better? Which kind of fraction do you like better? The one with the smaller number on top or the bigger number on top? Yeah, when you guys first learn about fractions, most people, and I guess I'm saying this because this is what I think. I liked it better when the smaller number was on top, because then you didn't have an improper fraction, and I didn't have to change it to a mixed number. Life was happy. So that's how I remembered what the horizontal asymptote is going to be. Because when you talk about horizontal asymptotes, what matters is the degree on the numerator and the degree on the denominator. Do you guys know what the degree of the denominator is? 1. It is 1 because there's an x here and it has an exponent of 1. What if the degree had, what if there's a squared on it, like this guy down here that you can't really see? That would be a degree of 2, right? What's the degree of this numerator? 1. The degree of this numerator is 0. There's no x up here, right? There's no x. And so our degree is 0 on top. The degree on the bottom is 1. So the smaller number is on top. The bigger number is on bottom. And when that happens, you know that your y, or your horizontal asymptote, equals 0. This always leads to a y equals 0 horizontal asymptote. You guys tracking? Yeah. The other scenario is this one right here. What's the degree on the numerator? 1. What's the degree on the denominator? Uno, right? They're both 1. So when they're both equal, like if the degree on top is equal to the degree on the bottom, you look at the leading coefficients to find your horizontal asymptote. So you look at the leading coefficients. For the top, the leading coefficient is 5 because it's connected to this x. The leading coefficient on the bottom is positive 1, not this negative one, because the x, which has the highest degree, has a 1. So you take this 5 and you take that 1 and you divide them. That is your horizontal asymptote. So right here, this guy at 5, y equals 5, is your horizontal asymptote. So when the degrees are equal, you just divide the leading coefficients. That gives you your horizontal asymptote. Well, what happens if you get a bigger number on top and a smaller number on bottom? That is no hori asymptote. No hori asymptotes. Okay? All right, I got too much going on here. Let me delete this right here. Okay. So, yeah, you can't fully abbreviate the word asymptote because it doesn't look right. But there's no hori asymptotes. Okay? So, what is there? What is there? If there's no horizontal asymptote, that means there's a slant asymptote. Slant asymptotes look like this, and you guys don't even have to worry about these right now. You still get your vertical asymptote, but your horizontal asymptote doesn't exist. Instead, a slant asymptote exists. And the short and skinny of it, guys, is you find your horizontal asymptote by dividing whatever it is, and whatever your remainder is, you just cut it off, and whatever is there, that is your horizontal asymptote, which is kind of interesting. But we're not working on that right now. All right, so last thing I want to talk about is domain of this. Whenever you guys are thinking about domain, always think, oh, it's all real numbers, negative infinity to positive infinity, but then you stop yourself and you go, wait a second, I can never, ever, 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 ever divide by 0, so what can x not be? It cannot equal 1, which happens to be our vertical asymptote as well. Could they be related? Yes, they can. Yes, they are. Can you guys tell your neighbor, or write it down and show them, what is the domain for number 1? If you said all real numbers except for 1, you're right. But I want you guys to write it in interval notation. So you would write it like this, right here. You would say from negative infinity to 1, not include 1. So you should have a parenthesis around there. If you put a bracket, that means including 1. We don't want to include 1. We want to exclude him. And then you combine that with 1 to positive infinity, and that's your domain. So your vertical asymptotes relate to what your domain is going to be. Your vertical asymptotes tell you what cannot be in the domain.